There's a theory called the 6 degrees of separation that states that any person on Earth is connected to any other person by no more than 5 intermediaries, or 6 steps. I've created a simulation to see how accurate this theory is, and also to map a framework of society to show things like how ideas spread, and eventually upgrade it to show more and become more accurate with the help of this community. We'll start the simulation with 80 people, and we'll likely increase that number in the future, but for now we'll start simple. One problem we'll encounter is that no computer can run 8 billion dots with all their billions of connections, and we can't scale the statistics we use of the 8 billion people on the planet down to 80 people because it will be to the negative powers. So for now we'll have to improvise. Data from 22 European OECD countries show that on average people have about 4 close friends and 5 close family members. So for now, we'll set each person to have 9 contacts, but I'll add variety soon, and levels of closeness, maybe in the next video. This is our first network. You can see that the average steps between 2 nodes is 2.2, and the minimum steps between 2 nodes here is 4, but on most of my simulations it comes up as 3. Compared to the real world's estimated roughly 6. You can click on 2 nodes and see how many steps it would take, the lowest amount of steps it takes between them. So node 47 knows node 12, which knows node 46. It's a mess right now and not too realistic because who knows who is completely random in this simulation. In the real world, if someone knows 2 people, those 2 people are more likely to know each other, creating friend groups. So let's add that. On Facebook, an average of 38% of people's friends know each other, so I set clustering to 0.38. So, now we have clustering, and because their positions are based on their clusters, it's looking a bit better. Now people's friends are more likely to know each other. You can see that if I click 2 nodes that are in the same cluster, they're more likely to have less steps than ones that are in different clusters. You can see even clearer when we color coordinate them. So, what's next? Well, not everyone has exactly 9 close connections, so we need to add variety. Introverts and extroverts, you could say. So I found this survey that shows the distribution of how many close contacts people have, not including family, and added my estimated average of 3 close family contacts to get our percentage distribution. And here we have it. Notice it didn't change the stats at the top very much, and that's because it still circles around a similar average. So how do we find out if our 6 degrees of separation is accurate if we can't simulate 8 billion nodes? Well, I came up with this scientific method. I record the max minimum steps between nodes for simulations with different numbers of nodes, put them in a graph, and use the curve of best fit to predict the value where the numbers of nodes equals the population of Earth. After a while of collecting data, I made a good old spreadsheet, and then used good old Desmos to plot my points. I recognised the trend to be logarithmic growth, so I inputted the curve into the graph, and it resembled my points well. I adjusted the variables A and B until I had the most accurate correlation. Now all I needed to do was substitute x of the equation to the population of Earth, which I took to be 8.27 billion. So now we have our answer, a max of 20 to 21, which is far from 6, so I wondered if maybe 6 was the average number of steps between 2 people. So I redone the table with the average number of steps between 2 nodes, then plotted another graph, done the equation again, and got 14.527, still way higher than 6. So why is our result so much higher than the theories? Well, I looked into the actual 6 degrees theory. The original 6 Degrees experiment, Milgram's Small World experiment, was designed to test how many steps it takes for a message to travel between two randomly selected people in the United States. In the experiment, Milgram asked participants to send a letter to a target person in another state, with a key rule: they could only forward the letter to someone they personally knew. Now, this experiment defined connections by simply personally knowing each other, whilst mine only included close contacts, so Milgram's experiment had much more pathways than mine did, resulting in a shorter average steps. So Milgram's experiment shows how many steps it would take between all contacts. For now, mine only shows how many steps it would take between core contacts. If you want to see me upgrade the simulation, subscribe and comment your suggestions. I'll see you in the next one.